We're starting our unit on trigonometry here, and we're first going to look at what we call similar triangles. So I'm going to identify first of all what congruent figures are. If figures are congruent, they have exactly the same shape and the same size. So I've tried to draw on this page triangle ABC and triangle DEF and mark on side lengths that are equal to each other. So if I were to cut out triangle ABC, I should be able to flip rotate it and be able to place it exactly on top of triangle DEF. For this particular triangle, you'll notice that side AB has been marked with a single tick mark or slash here. That means that that length is the same as the length that's also been marked with a slash on the other side, or the other triangle here. So side AB would match up with DF in some way, shape, or form. Similarly, side BC will match up with this side, and side AC matches up with this side length. So in this case, we have the side connecting A to B joining or matching with the side connecting, and I'm going to call it FD. Now there's a reason why I'm calling it FD. If you look at A is the vertex between the single slash and the triple slash, and that corresponds to vertex F because it's the angle between the triple slash and the single slash. So if I want to say that side AB, it's going to match up or be equivalent to side FD. Okay, so the order that we say these things actually matters. And then we have vertex B, which is between the single and the double slash marks. That matches up with D. And that would imply that BC, so side BC, is going to match up with side DE in the other triangle. And then lastly, we have side CA in the first triangle, and it's going to match up. So C goes between, so that would match up with E because it goes between the triple and the double. It's going to match up with E and F. Okay, and so when we state these triangles are similar to each other, we could say that triangle, that's my triangle symbol, triangle ABC is congruent. I think I said similar and I meant congruent. So congruent is actually an equal sign with a third line. So that's exactly equal to, congruent to, triangle. So A matched with F, B matched with D, and the C matched with E. So order matters here. Triangle ABC is congruent to triangle FDE. So sides are equal. This also would imply, as I said before, angle A is equal to angle F, angle D, whoops, wrong, I've got to do my other triangle. Angle B is equal to angle D, and angle C is equal to angle E. Okay, so you'll notice that all the things in the first column come from the first triangle, and all the things in the second column here come from the second triangle. Similarly, up here when I was comparing the side lengths. All right, so similar figures are somewhat like congruent figures. They have the exact same shape, but not necessarily the same size. They can be an enlargement or a reduction of the other figure. So in this diagram, I have triangle ABC, and I did mean to match things up here with angle A matching with angle D in the other triangle. So angle A is matching with angle D. I didn't write this on here. It's very hard to mark the angles with the software that I use here, so unfortunately. So I'm circling the angles in the corresponding colors to show that they match. To have the exact same shape, what we need is the angles to actually equal each other. So angle C has to be the same measure as angle F. Angle A has to match up with the measure of angle D, and angle B has to match up with the measure of angle E in this case. To say that our two triangles are similar to each other, we're going to say triangle ABC, and this time it's like an equal sign, but instead of a third line, we make a wavy line. And that means similar to Actually, that is congruent too. Sorry. Let me erase that. That is another symbol actually for congruent too. So you can use your 3 straight lines, or you can use your equal sign with the wavy line over top. Let me fix that up. This is just supposed to be the wavy line, okay, without the equal sign. So similar to triangle DEF. And again, I'm matching up the angles that correspond to each other in that proper order there. So what this means then is angle A, we said, equals angle D, angle B is equal to angle E, and angle C is equal to angle F. Now, as far as side lengths go, they're not equal here, but what happens is they are proportional to each other. So if I take the side AB in the first triangle, and I were to compare it to side DE in the second triangle, because those are corresponding sides, that ratio, that division, would be equivalent to taking side AC in the first triangle and dividing it by the side length DF. And that ratio is also the same as BC's side length divided by EF. And this is helpful. This is the basis in trigonometry and doing our primary trig ratios with right angled triangles. This is the premise of that. So we need to make sure that we understand that. So to be able to prove that triangles are similar, we can use one of the following things. We could either take a look at our triangles. As long as we have 2 pairs of angles that are corresponding angles that are equal to each other. So angle A is shown to be equal to angle D because they're both marked with the letter Y, and angle B is equal to angle E because they're both marked with the letter X. Then by default the third angles will be equal, and that will preserve the shapes, and the triangles will be similar. So to actually prove that or to explain that, we can do that in words. We could say angle E equals angle D. Just move that down a little bit. I'm going to write something above this in a minute here. Angle A is equal to angle D. It was marked on the diagram, marked as equal on the diagram. And then we have angle B equaling angle E, also marked as equal. So as soon as you have 2 angles that are equal, you can therefore conclude that excuse me, triangle ABC is similar. That's supposed to be that wavy line. It's the tilde symbol on your keyboard. It's similar to triangle DEF. Okay, and that's by angle, angle, similarity. So this is my justification to the right. It's all the explaining your reasoning, how you know that those triangles are similar. So to begin this, it's like a little paragraph here in math terms. I'm going to introduce my paragraph by saying, or introduce my proof by saying, in triangle ABC and triangle DEF, these are the things that I know are true, and therefore I conclude that they are similar to each other. All right, so that's one way to prove. As long as you have 2 pairs of angles, corresponding angles that are equal to each other, then the triangles have to be similar to each other. There's a couple other ways we can prove similarity as well. Another way to prove that triangles are similar to each other is through the side angle side similarity theorem. If 2 pairs of corresponding sides are proportional, so if you do the ratios and they equal each other, and the contained angles are equal, then you know that the triangles have to be similar. So let's look at our 2 triangles here. I'm noticing that in the first triangle, I have angle A being marked as X, as is angle D. So we've got 1 pair of angles that are equal, and it's contained or smashed between 2 sides. And when I compare my side lengths, I want to go smallest to smallest and then my biggest to biggest. And then if I had a third side like I do in the next example, I would go middle to middle. So I want to compare those ratios. So let's try 5 compared to the 2.5. And my dog's trying to make a little home if you hear some scratching. That gives us a 2 here. And then we compare the other set of sides, the bigger to the bigger. I'm going to do 7 divided by 3.5. That also gives us 2. So the sides are proportional. So to write this up, I start my little math paragraph. I'm going to say I'm going to work with triangle ABC, in triangle ABC and triangle, and I was nice because I matched these up. D matches with angle A, angle D matches with angle A, and then the B would correspond to the E, and the C corresponds to the F. We know that angle A, so angle A is equivalent to angle D because it was marked on our diagram, marked as equal. And then, oops, equal. That's supposed to say equal there. It's not very tidy. Okay, and then we know that the side lengths, the pair of side lengths, AB compared to DE, that was equal to AC compared to DF, and that was equal to 2. So therefore we can say that triangle ABC is similar to, wavy line, triangle DEF, and that's through side, angle, side, similarity. So that angle has to be contained between the two sides or we can't use it. All right, the last way to prove that we have similarity is if all three sides are proportional. You don't know anything about the angles necessarily, but if you can compare the matching side lengths, so the smallest compared to the smallest, let's try that. 5 divided by 2.5, that's equal to 2. And then the medium to the medium, so we'll go 7 compared to 3.5, and that's 2. And then the largest compared to the largest, 8 divided by 4, is also 2. So we have three pairs of corresponding sides that are proportional. So we write a little paragraph here in triangle ABC and triangle DEF. Matching up those angles, we know that AB compared to DE would equal or is equal to BC compared to EF, and that's equal to AC compared to DF. Those were all equal to 2. So therefore, triangle ABC is similar to triangle DEF by side, side, side similarity. So let's actually now take a look at this pair of triangles and do the proof that they are similar. So we're given all three sides, so I'm thinking side, side, side. You're going to compare the smallest side to the smallest side. You're going to compare the medium side to the medium side and the largest side to the largest side. So calculate those ratios and make sure they all equal each other. And then write your little paragraph. And remember, you want to correspond your angles with each other when you write your triangles' names. So give that a shot and then play the video again and see how you did. Okay, so when I calculated the ratios, I got that they are all 1.5. And now I want to see how my angles actually correspond to each other. So I'm starting with triangle A, then B, then C. So A is the vertex between the side that I underlined in blue and the one I underlined in red. That would correspond to vertex Q because it's between the blue and the red. So triangle, when I write its name, I'm going to put this in the proper order. So A matches with Q, and then if I look at angle B, B is between the blue and the green, R is between the blue and the green. So R has to come next, and then by default, P will be last. So order matters here. We want them to correspond, and then we're going to say that AB compared to QR, so I can just read this off of here. First two compared to first two, that's equal to the second pair, BC over RP, and that is equivalent to the AC over QP. So once I write them correctly at the top, it's really easy for us to write the side lengths in the correct order. So therefore, our triangles are similar by, is similar to triangle QRP, whoops, QRP by side, side, side similarity. All right, so that's your goal for homework, is to use these.